Hi, today I want to continue the video on microservices features and architecture. In previous videos, we already discussed about a lot of features like service discovery, API gateway, fault tolerance, circuit breaker mechanism. These concepts we already discussed. I hope you can see these videos in my channel if you want. Now I want to continue with the additional features and that are required to or design a complete end-to-end microservices architecture without any problems. So I want to explain the inter-service communication and distributed tracing. I explained it, and basically I want to explain the inter-service communication today, and also some part of the Spring Boot actuators concept. How we can monitor the endpoints for monitoring, gathering metrics, performing health checks, externalized configuration. So many things are there. So just remember the concepts of microservices architecture, very good architecture. We can use it to develop any complex system using microservices. We can actually split the functionalities to atomic level and develop atomic services. So these services are self-contained, and they are very flexible to scale, and we can scale it as many number of services that we want to scale. uh, these are the generic, these will be kind of generic services. You can consume these services from any other services that are developed by different technology. Okay, since these are RESTful services, right? So yeah, okay, now let me proceed with the inter service communication, and after that I will explain you a little bit of actuators also. Okay, now what I'm doing is here I'm just copied that concept inter-service communication, microservices, example code. Okay, we need that. So you can see there are two ways we can actually establish inter-service communication microservices. First one is synchronous services, and second one is asynchronous approach. First one is synchronous approach, second one is asynchronous. Let me explain what is a synchronous approach is. So whenever service A is calling service B, okay, service A has to wait until it gets the response from the service B. So it is service A is depending on the service B response. Let's say if service B is taking a lot of time, right? Then service A has to wait, right, until the service B is rendering the response to service A. It has to wait. So the service A is depending on the service B response. That is called synchronous approach. So synchronous approach benefits are, it is very easy to implement, and most of the applications we use the synchronous approach. Simple to medium projects we can use synchronous approach, establishing this kind of communication among the multiple services. Um, it is very straightforward approach, but the problem is, the downside of this synchronous approach is, sometimes if you need a kind of streaming applications or a kind of acknowledgement related applications, some complex applications, if there are thousands of services and you want to establish a communication, and if latency is your problem, right? If sometimes some applications they require very low latency, and something has to be done immediately without depending on other services acknowledgement, right? So in those scenarios, the synchronous approach will not work. There we have to go for a synchronous approach. It is a messaging messaging based communication, where you actually invoke service B from service A, and you the service A will not wait for the response for service B. It will just publish the message and leave it there, right? And whatever other service from other side is trying to consume the message from service B, it will consume it and it will use it for processing purpose. So it is a simple brief explanation about the synchronous and asynchronous concepts. Okay, in synchronous communication, the client service waits for immediate response from provider service, as I told you. So one of the examples is web client, modern non-blocking in Spring Boot. Web client is a modern reactive client recommended with the Spring for making HTTP request. We have many examples. You can see. So one of the let me explain how we can use the web client. You need to inject the dependency of the web client, web client, and then what you are doing here, you need to build the URL, service URL. So I'm going to pass HTTP slash slash book service, and I have used web client builder. Okay, basically override it. We actually inside the constructor, what we are doing, we are actually passing the builder object here, and then we are building the service, right? Configure the base URL and use the service discovery. So basically we are actually forming the URL, and passing this service URL here. And after that, you see what we're doing. There is a mono of type book type, and a get book ID. Inside we are passing parameter ID parameter, and return this dot web client get off, dot URI. What is the URI here? Basically the endpoint URI, we need to pass a slash books slash ID we are passing dynamically here, you see, and retrieve body to mono book class. So it is a non-blocking request, returns a reactive type. Okay, so this way we can render the we can render the book object by passing this ID. Okay, this is a modern approach. Web client is a modern approach in Spring Boot framework, Spring framework. You can use it to get it right. So this is a very good example. Other thing is a fin client. Fin client, you can see declarative interface for REST calls. So often with built-in load balancing when used with the Spring client. So we can also use a Spring fin client. You see here, basically we have this main application fin client and a main class, and here we need to create an interface for the book service. You see, book service is there. I have created a interface with the book client, and I have used at the rate fin client annotation, and its name is a book service. We need to pass that, and after that you can use a get mapping, slash book slash that ID inside braces, and we have a simple method declaration get book. And inside your implementation service class, you need to auto-wire that you need to inject the dependency, the constructor injection. You can see injecting the dependency through a constructor injection, and then fetch book details. You can see here passing the book ID and returning book client dot get book of book ID. So it is also straightforward. What we are doing, we just declared a fin client interface, for marking the endpoint service URL, and then we are simply using that book client interface object, and we are simply, book client interface, and we are just getting the details simply, right? This is the other way of synchronous communication. You can also use a REST client. REST template is there. You can also use a direct HTTP client. There are so many ways you can actually invoke the synchronous approach. It is very straightforward forward approach, but modern way of using this synchronous approach is a web client. One is web client, other thing is a fin client. And most of the projects, they also use a rest template, rest client also. Okay, just keep that in mind. And other thing is asynchronous communication. Asynchronous communication, messaging queues, you need to use the messaging queues. Let me give an example. If you take a e-commerce application or any banking application, you can take any application you want. So once order is placed, you need to get the confirmation details, or you may need to get the shipping details. You need to get the alerts, right? The notification alerts. So for that, we generally use this asynchronous approach. We will just publish the message to the queue, and the consumer classes, they'll read those messages and they'll actually generate the alerts, alerting mails, alerting SMS, or whatever you take. If you take a banking application, once the customer withdraws money, right? It has to send the SMS, right? Alert. It has to send that. So we'll simply publish the alert, and alert can be, it doesn't matter that alert should be immediately triggered, right? Sometimes the alerts may come after some time. So here you need to understand the requirement of business case scenario. Whenever the kind of, whenever the customer uh, uh, customer, it will not affect the SLA. Basically, it won't affect the uh, business client very much. There are some high priority requirements where SLA is very important, right? The time latency is very important. You need to reduce the SLA. You need to reduce the latency. You need to get the response immediately once something is happened. But for some of the requirements, like sending a mail, or sending SMS, sometimes they can be delayed. In this scenarios, it won't affect the customer, right? So once the customer withdraws money, he may get the SMS after 5 minutes, 10 minutes, 7 minutes, so whatever the time it is. The customer won't bother about it. He always wants something to be displayed. But anyhow, with these latest technologies, we can trigger the SMS, or we can send the emails notification immediately. We are sending it within a minute, or within a seconds also we are doing it. But what I'm telling is, asynchronous approach. Most of the times, we use them for sending alerts, sending notifications, shipping details. We prefer the asynchronous approach. Asynchronous approach is required where the so this kind of alerting system design. And other way of using alert asynchronous communication, I'm just giving examples before going deeper into the see asynchronous communication, how we can use it. I'll also show the example here. You can see other thing is, let's say I want to transfer terabytes of petabytes of data from Oracle database to MongoDB or Cassandra database. How you can do that? So it has to be done based on real-time updates. Okay, for example, for customer in a banking application, for storing customer data, we need a relational databases, right? For any non-sensitive data, for which is not a transaction related data, so we can store the data into MongoDB. But both databases should be in sync. Whenever customer withdraws something, deposits something, it's a transaction made. I want some information immediately get stored in the NoSQL databases for monitoring purpose, for logging purpose, for for data storage or something, whatever the reason it is. Then I need to establish the I need to publish a message in a synchronous way to the queue as soon as the transaction occurred. and leave it there. Immediately other side the consumers will consume that message and they will process the message, right? So that's how we can also use this asynchronous communication. So we can use Apache Kafka here. I already explained this how we can actually consume this Kafka listener and Kafka template in other videos. You can check the video there, and it is there. How you can use the Spring Boot with the Kafka. There is a video I have explained the code example there. You can see that. So basically, what we are doing, we are using Kafka template here to send to publish a message to topic. They named it as a order events topic. And once you publish the message into the Kafka topic, and you can actually consume that using at the rate Kafka listener annotation. You just need to use this annotation for the method, consumer method. You have a class inside that you will actually use this Kafka listener uh, that will listens to your messages that are published to the topic if you use this consumer annotation. So that way, you can establish both, synchronous and asynchronous. I just wanted to explain you what is the synchronous and asynchronous communication, how you can implement this both the approaches in microservices architecture. Okay, that is the thing I wanted to explain in this video. Okay, and now I want to explain the Spring Boot actuator concept, right? Uh, Let me explain you that when as well Spring Boot actuators, uh, microservices example. Okay, you can see here. Okay, Spring Boot Actuar basically provides a production ready features to help you monitor and manage your microservices in production environment, right? You can actually monitor all the endpoints and application status, health, performance. You can actually see all these things. So for that you need to include Spring Boot starter actuator. So in pom.xml, right? In build tool pom.xml, you need to include that. Other thing is you need to enable the endpoint management endpoints web.exposure include. I just mentioned it at start. That means you are going to expose all actuator endpoints over the web, or you can also expose only few endpoints, and you can actually disable endpoints, other endpoints also. That way you can see that. Okay, now you see after making these two changes, you will be able to access the actuator slash health endpoint. Okay, what it will do, it provide the basic application health information which can be integrated with container orchestration platforms like Kubernetes for liveness readiness probe, and slash actuator slash info displays the arbitrary application information. You can customize the data shown in the info, and if you want to see the metrics slash actuator slash metrics. If you want to see loggers, allows to you the dynamically modify the logging levels of your application loggers at runtime. You can also see slash actuator slash http trace displays the information about the last 100 http request response exchanges. Okay, so monitoring the microservices in larger system. You see, each services exposes its own actual endpoint, right? To centralize the monitoring, you can use tools like a Spring Boot Admin, a community project that aggregates, visualize the data from actuator endpoints across all your, across all your microservices central dashboard. So as I told you, for each and individual service, we will enable the actuator, and we want to centralize all these details into single dashboard, right? How we can do that? We have many tracing softwares available. You can see Prometheus and Grafana. For distributed tracing tools like Jipkin, you can use the Jipkin, right? ELK stack, you can establish ELK stack also. There are so many monitoring systems, monitoring softwares available in market, third party market. You can use them. Okay. And you can actually monitor the system information and all. And how you can see, I want to go a little deeper into trace id and span id, how we understand the logging. Okay, I'm giving you an example here. Example code. So first thing is you need to include all these actuator dependencies, and see for micrometer tracing, open telemetry, you need to include these dependencies. Okay. After that, in properties file, you need to specify these details, logging log details. You see application name, trace ID, span ID. You need to mention these details. Okay. This there are two entries, trace id, span id. You need to understand what are these. Okay. Now what we are doing here, see in the uh, we have a one endpoint get mapping, simple hello endpoint. It just printing logger info. And you see when you run the application, make a request slash hello, the console logs will automatically contain the service name, trace id, span id in the format you see here. Service name, trace id, span id. A trace id is a unique for the entire request across all microservices. Okay. Yeah, it is very important thing. Let's say a request will be identified by trace id. It is a unique id, and for that way you can understand how this particular request is actually propagating throughout multiple services. You have a visual dashboard, centralized visual dashboard, and for a particular client is logged into your website for banking application, and you want to see how that request is propagated to multiple microservices. Okay, using this id you can actually see that. And span id is unique for the current operation within the service. This will change when calls are made to other services. Span id is basically within a request within the current operation of the service. Okay, how it is, you can see here, when calls are made to other services, internal operation becoming the parent spawn for subsequent span. So span id request can be spawned into multiple um, internal operations, right? For each one that we I need a span id. Getting right, there is a request, one request trace id is there. For the trace id there are multiple spawns has to be performed to complete a certain task. So for that it has to assign a span id for each spawn of process at flow. That way those details, those paths, those flows will be identified. So whenever you are going to create a logging configuration application properties, you always has to make sure what is the application name, what is the trace id, request id, what is the span id. From the request, what are the how many number of spans are going to be explored. These details you need to specify there. Okay, for a better design of the system, if you are going to build a proper architecture of the microservices system, you need to follow this proper tracing pattern. If you take a distributed architecture, distributed microservices architecture, We may have many services deployed in different servers, and they will communicate using either synchronous or asynchronous approaches. Right? You just remember that they may communicate either through a synchronous approach, or some part of the distributed architecture system is developed using a synchronous communication, and other part wherever it is required, alerts or shipping details, notification details, sending mails, SMS, you may require the asynchronous approach. The complete microservices distributed architecture can be combined with this both approaches, right? If it is a complex system, so that time you definitely require this distributed tracing algorithm, and you need to have a centralized admin monitoring tool. You cannot have multiple visualization monitoring tools for each and every service. If the centralized if the distributed architecture is having multiple nodes and multiple services deployed and multiple clusters, and you want to monitor all these details in a single dashboard. Because even if there are multiple components and multiple servers applications deployed on different distributed cluster, you have to see how the request is propagating, right, from beginning to end. You have to understand the path of the request. You need to understand the flow, and what are the internal subsequent operations also you need to identify using a span id, right? So that is why you require this both trace id and span id. You need to implement the proper distributed tracing mechanism to avoid the problem. It is a mandatory thing, because if this is not there, this kind of implementation tracing monitoring feature is not implemented in your application, if something is broken tomorrow, how can you identify the errors? How can you identify the exception? It would become very difficult to identify the issues and exceptions. Right? Sometimes you have to understand these things. You need to, for example, you take a asynchronous approach. You published a message in particular component, and other side that message was not delivered. It was not consumed. Something is broken. How can you identify these details? The first thing is to find out the root cause. You need to go through the logs and you need to see them, right? The first and primary root cause analysis starts with understanding the logs, looking at the logs and seeing how the request is floated, propagated, where it is broken and why it is broken. You can understand, you can debug it, you can troubleshoot the issue very easily if you implement a proper distributed system. Okay, I hope you get all this information. Okay, let me some other. What is this? Now I hope you understood both uh, synchronous approach, inter-service communication, and actuators concept, right? I hope you see what I have explained here. I have explained inter-service communication. I also explained you the actuator concept, right? So these are the main things. So distributed tracing also I have explained you. Along with the actuators, I explained you distributed tracing also. Cloud native support, Spring Boot integrates seamless with the cloud platforms, containerization tools with Docker, Kubernetes facilitates easy deployment, scaling with modern. You can actually include any Docker files. You can also include any Jenkins files with the Spring Boot. You can also containerize the any Spring Boot application in a simple way. No, very good native support for the cloud. There is a cloud native support to the Spring Boot framework. That is why Spring Boot is a preferable framework. Microservices for also for building microservices. It is a very good framework. So, for the overall microservices ecosystem features, Spring Cloud integration, we need to design the proper service discovery and registry, right? I explained you this concept for discovering the for registering the client services so that dynamically the services will be identified so that communication will be established properly. So service discovery is required. API gateway is for configuring the all cross-cutting scenarios like authentication, authorization, and logging, routing, load balancing, so many cross-cutting concerns across multiple services we can actually configure here. Fault tolerant circuit breaker mechanism, so you want to build a resilient microservices. As I told you, if service B is failed when service A is trying to invoke, if service B is not responding due to some issues, then it would be a problem. So whenever something is broken, we should immediately render a proper error message or a proper with the required details, fault tolerant and fallback message. You need to give the fallback message immediately, so that way system will be perfect, and even client will not get agitated um, with the with the improperly constructed system, right? It should be a proper system, so that way you can give a fault tolerant and circuit breaker. And also fault tolerant, sometimes service B may be online after some time, so immediately that should render a response. Until that, it should show some fallback message. So it is called a concept of fault tolerant or resilient system architecture. We need to do that. As I told you, inter service communication, distributed tracing, cloud native support is also there. Okay, and all other auto configuration, starter dependencies, embedded servers, production ready features, externalizer configuration. Okay, REST endpoints. These are the features actually, core Spring Boot features. These are for microservices. They are readily available when you use the Spring Boot framework. Another thing, these features we need to integrate using a Spring Cloud integration. Right, all microservices ecosystem features you need to integrate using a Spring Cloud integration. There are Spring Cloud features, dependencies provided by the Spring Boot framework. You need to include all this. I hope you understood this video. I think I completed this microservices architecture feature. We can discuss further about another frameworks details in coming videos. Thank you all. Thank you for listening.